Okay, we're on page 247. This is the lesson 9.2 independent practice. For as much of this worksheet as possible, I suggest that you read and try the problems and then use the video to check your answers. Number 9 reads, multiple representations. Use the grid to draw 3 different rectangles so that each has an area of 12 square units and they all have different widths. What are the dimensions of the rectangles? So there's different ways to do this. It's got to be a perfect rectangle. It can't be any old shape you want. It's got to be a perfect rectangle. One rectangle that you could use would be a really long and skinny one. For example, if I went like this and drew a line that was how long? I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 long and 1 wide. Now that's kind of a funny rectangle, but it's still a rectangle. That's a 1 by 12. And you can do 1 times 12, or you could do 1 and use the word by 12. That's a 1 by 12. What else could we make? Well, we could make a 2 by 6. And if you're wondering how I'm getting these, I'm doing my facts. 1, 2, 3, 4, 5, 6. I'm doing my facts. I'm asking myself what times what equals 12. 1 times 12 is 12, and 2 times 6 is 12. And the last one would be, and it doesn't matter if it's tall or long, it doesn't matter, 1, 2, 3 by 1, 2, 3, 4. So the 3 different rectangles you could get would be a 1 by 12, a 2 by 6, and a 3 by 4. Those are the dimensions of the 3 different rectangles. Alright, question number 10 reads, Brandon has 32 stamps. He wants to display the stamps in rows with the same number of stamps in each row. How many different ways can he display the stamps? And explain. Well, there's a bunch of different ways to do this. One way to do it is he could do 1 row with 32 stamps. We should probably go over here and make a list, because it says how many different ways can he display the stamp. So we should probably do this. Well, I know what we're going to do. This question right here we're going to start with, we don't know the answer yet, so we've got to get all our answers first. This is how many different ways can he display the stamps. We're going to put that first. We're going to do blank different ways. And then we're going to go ahead and list them. And the first way, I was just starting at the beginning, is do 1 row of 32 stamps. Or he could do 2 rows of, well, how many would be in 2 rows? It'd be 16. Or he could do 3 rows. No, he can't do 3 rows because you can't divide 32 by 3. He could do 4 rows. How many would be in each row? 4 rows of 8. He could do 5, no. 6, no. 7, no. 8. Now, I already used 8. But if you think about it, I can repeat it, because this 8 right here means 8 stamps in 4 rows. This one would be 8 rows, and how many stamps would it be? 8 rows of 1 stamp, or of 4 stamps. So in this question, it's okay to repeat and go backwards. So far I've got 4 different answers. 1 row of 32 stamps, 2 rows of 16, 4 rows of 8, 8 rows of 4 stamps. I could do 16 rows of 2. And the silly one would be 32 rows of 1. That's 6 different ways, and that is the correct answer to number 10. Cool, let's move on. We're on number 11. It says, how is finding the factors of a number different from finding the prime factorization of a number? So what we can do is just show an example, and then we'll summarize it. So here's an example. If I wanted to find the factors of 16, I would go 1 times 16, and 2 times 8, and 4 times 4. Those are the factors of 16. Is that the prime factorization of 16? It's not, because some of those numbers aren't factors. So the prime factorization of 16 is 2 times 8, and 2 times 4, and 2 times 2. So the factors of 16 are 1, 2, 4, 8, and 16. The prime factorization of 16 is 2 times 2 times 2 times 2, which is equal to 2 to the 4th power. Are those the same thing? They're not. So I'm going to label which one's which. These are the factors, and these are the this is the prime factorization. And we should summarize it. And we could say something to the effect of, maybe I'll type something to the effect of prime factorization is only prime numbers, while listing factors is can be while listing factors is all the factors, even if they're not prime. Okay, that's probably too long of an answer, and we just kind of have to live with that sometimes. So what I did here for number 11 is I showed my work in order to explain it, and then I wrote a summarizing sentence. I hope that's not too much for you to squeeze onto the lines. Okay, let's move on. I might just move this up, and I'll leave this one here in case you need it for longer. That summarizing statement's really probably good enough without the example. Numbers 12 through 15 ask to find the prime factorization of a number. And I just showed you how to do that using a tree diagram. You could use a tree diagram for these, or you could use a ladder diagram. I don't know which one I'll choose. I'll figure it out as I go. But one thing I do is show lots of work on these. Number 12. This might be the hardest one. It's 891. And I think I'll do, do I want to do a tree for this one? This might be a really good one for a ladder, to be honest. I don't know that it really matters. I think I'll do a ladder because I often prefer tree diagrams. And so I'll do a ladder diagram just to be different here. So I'm going to put 891 right here. And I know it's not divisible by 2 because it's an odd number, but is it divisible by 3? I think it is. What I'm going to do actually here is rewrite this using division by 3 and see if it's divisible by 3. 3 goes into 8 twice. 2 times 3 is 6. I get 2, bring down this 9. 3 goes into 9 times because 9 times 3 is 27. 29 minus 27 is 2, bring down this 1. 3 goes into 21 7 times. 7 times 3 is 21. So I don't need this anymore. I just need to remember to myself that if I divided by 3, which is a prime number, I get 297. And now I need to make another guess as to what 297 is divisible by. I'm going to try 3 again because it's still an odd number. It's not an even number. And even numbers would be divisible by 2. Does 3 go into 2? It doesn't. Does it go into 29? It does. 9 times because 9 times 3 is 27. 29 minus 27 is 2. Bring down this 7. 3 goes into 27 9 times exactly. 9 times 3 is 27. I'm done. So I need to write that 297 is divisible by 3, and the answer is 99. Now I don't need this stuff anymore, and I think that all of us, everyone watching this video, and myself included, can use our facts the rest of the way. Is 99 divisible by a prime number? It is. It's divisible by 3, or it's also divisible by 11. It doesn't really matter if you choose 3 or 11. Like I could put 11 right here. Is 11 a prime number? Yes. Does it go into 99? Yes. How many times? 9. 9 is divisible by 3. Does 3 go into 9? Yes. How many times? 3. I'm not done. It kind of seems like I might be done, but I'm not, because 3 is not 1. I have to divide until I get a quotient of 1. What's 3 divisible by? It's divisible by 3. How many times does 3 go into 3? It's 1. So the prime factorization of 891 is 3 times 3 times 11 times 3 times 3. I'm going to check that before I record my answer. 3 times 3 times 11 times 3 times 3 is 891. So I got it right. Now how do I write that? I don't write this as 3 times 3 times 11 times 3 times 3. I write this as the base of 3. I count how many there are. 1, 2, 3, 4. So it's 3 to the 4th power. And then I multiply by 11. It's 3 to the 4th power times 11. Right on. Let's check out 504. The next one. I'm on number 13. And I I don't know, I guess I'll do a factor tree for this one just because it's different. If you like the ladder diagram, that's fine with me. One thing I like about this problem is I know that 504 is divisible by 2. I like dividing by 2 because it's easy. Now if you can't do this mentally, you need to go over here and do 504 divided by 2. I can do this mentally because dividing by 2 means just to split right in half. And this is easy to split in half because it's almost close to 500. And 500 split in half would be 250. And 4 split in half would be 2. So the answer is 252. And 252 is divisible by 2 because it's an even number. Even numbers are divisible by 2. This one's a little harder to split right in half. I can do it, but I'm just going to divide. 1 times 2, or 1 goes into 2 once. I think I said that wrong. 2 goes into 2 once. 2 goes into 5 twice. And 2 goes into 12 6 times. 6 times 12, 2 is 12. So I get 126, which is still even. So I'm going to divide by 2 again. And I might run out of room, so I'm going to have to start writing really small. I've got 126 divided by 2. This is going to be 63 because 2 goes into 12 6 times. 6 times 2 is 12. And 2 goes into 6 3 times. 3 times 2 is 6. So I finally have an odd number, which means I can't keep my perfect pattern up where I just branch it out. I need to rewrite this. It's too big. I don't have any mistakes here, but it's just too big, so I'm going to rewrite it. It's 504. It's broken down into 2 times 252. 252 gets broken down into 2 times 126. 126 gets broken down into 2 times 63. And I can't have my perfect pattern here where I can't put a 2 here now because 2 doesn't go into 63. But 3 does. And you should probably know that because 3 goes into 60 20 times, therefore goes into 63 21 times. Not to mention your multiplication chart will tell you that. And then 21 is simply 3, which is a prime number, times 7. And that's it, I got them all. You can check it though if you want. I don't want you using a calculator to solve these, but you can use a calculator to check. 2 times 2 times 2 times 3 times 3 times 7 is 504. I got it right. So what is that? There's 2 as a base, but there's 3 of them, so it's 2 to the 3rd power times, there's 2 3s, so that means 3 to the 2nd power times 7. Those are all the prime numbers. Alright, we're getting a little low on time, so we've got to hustle through these last couple. Luckily, this one's really simple. 23 is a prime number. Prime factorization of prime numbers just gets written as the number. You could just write 23. You could actually write 23 to the 1st power, but you don't need to. It's just 23. That's a prime factorization. We don't write 1 times 23 because 1's not a prime number. 230, I'll use another ladder diagram. 230 divided by 2. 2 goes into 230 115 times. What I did there to do mentally was I divided 200 by 2 and I got 100, and then I divided 30 by 2 and I got 15, therefore it's 115. 115 is divisible by 5. I can do this one mentally as well. I can do it by dividing as well. Doesn't really matter. 5 goes into 11 twice. 2 times 11, or 2 times 5 is 10. 5 goes into 15 3 times. 3 times 5 is 15. That should make sense because just 20 times 5 would be 100, and 3 times 5 would be 15, which makes 115. So I get 23. 23 is a prime number. So what I actually do is I divide what goes into 23. 23 does. 1 time. When I get this 1 here, it means I'm done. It also means that I have my prime factorization. 2 times 5 times 23. There's no exponents here because none of the numbers were repeats. I'm going to check my answer. 2 times 5 times 23. That should make sense because it's going to be 10 times 23 is 230. Alright, well we're out of time for this video, so the next video we'll do numbers 16 and 17.